Hello everyone and welcome to part 7 of a multiple video series covering the operation of electric circuits with a focus towards electrical quantities, where today we will be covering waveforms, and this is actually the last part of that 7-part series. It's important to note that waveforms are not always constant in time. Periodic waveforms particularly is a time-varying waveform repeating itself over intervals of time greater than 0. The repetition time, t, of a waveform is called the period of the waveform. For a waveform to be periodic, it must continue indefinitely in time. The frequency of a periodic waveform is the reciprocal of its period, with the units being hertz. Sinusoidal or cosinusoidal waveforms can be described by the following formula. Within this formula, we have the amplitude of the waveform A, the phase offset, which is the symbol phi. If the offset is 0 degrees, we would get a sinusoidal waveform as a result. And if we had 90-degree phase offset, this would result in a cosinusoidal waveform. The omega is also known as the radiant frequency of the wave, can be identified by 2 pi times the frequency, or 2 pi divided by the period t. The average value of a period waveform is the net positive area under the curve for one period divided by the period. Lastly, the root mean square, also known as the effective, is the square root of the average of the function squared with respect to time. Determining the square of a function f of t, then finding the mean value in fact, and taking the square root yields the RMS value. This is found useful when comparing the effectiveness of different sources in delivering power to a resistor. For example, the effective value of a periodic current is a constant or direct current value, which delivers the same average power to a resistor. Now that concludes our crash course introduction to waveforms, and also concludes our coverage on electrical quantities. Next we'll be covering lumped circuits elements, so make sure you go check that out.